Okay, now we're recording. Screen and share that. Okay. So here on the day-to-day stuff, right? We're on, what are we on? Day 8, I think, right? Day 8, right? There it is right there. A weird will riddle. If you click on that, there's a copy of it right there. That's where I was reading it from. Okay, you got that? Okay. So, oh, that's the opening one. So you can kind of see what we're doing today. We're doing chapter 6 here, right? Fractions and rational numbers. Thank you for all the people that have sent in early all your assignments. I got like a whole stack of them already done and almost all marked. And then I'll send those out tomorrow. Then again, once I get those sent out tomorrow, I'll scan them back in so you can get them back. If you want to email me, I'll send you your current mark too. Because I have the spreadsheet all done up, but I'll put that in so then we have 3 things in there, 2 assignments and 1 test in there. So then
can we submit other assignments early, like assignment 3 if we're finished it? Or will it get mixed up with others?
It all comes as a separate thing, because what happens is when I get it on my screen, like let's say you send it to me and I look at the PDF and I click on it, I can see right away, right at the top, it says assignment 2, assignment 3, assignment 4, assignment 5. And then I print it off and I have a folder for them. So if you happen to do that one ahead of time, I'll just put it in that folder and keep it rolling.
Okay.
Oh yeah, I don't mind if you send stuff in early. Just don't expect to get it back right away, because the problem with it is other people haven't finished it, right? But I can tell you your mark. Like I can send you your mark on that. That's no problem. Okay. So that is the opening activity. So what we got is 6. So 6 is on fractions. And there's 6-1 to 6-4. I'll put it up in a sec. We'll do 6-1, 6-2, and then do some questions. And I think I put the practice questions on there for those that don't have the book, or I think everybody should have the book. I think the only one that doesn't have the book is Lacey. She just has an older version of it. But I think everybody else should have the book by now. So those are right there. There's the questions. Then we'll do that. And then I have some activities. And then we'll see which ones we can get through. I have lots of activities here, but sometimes, like yesterday, we ran kind of late. So I apologize for that. We went over the time limit. We might not get to all the activities. And I'd hate to do that, because look what they're called. Fun fractions. Oh my goodness. How could you not want to do fun fractions? Oh, I'll tell you. Okay. There we go. So let's open this up. Sorry, stop sharing that. Open this up. Once. Share screen. And yeah, that's the one I want. Okay, perfect. So let's slideshow. Okay, here we go. So what we're going to cover today is, like we did natural numbers, right? We did whole numbers, and then we did integers, right? Remember natural numbers, 1, 2, 3, 4. Whole numbers, we added 0. Integers, we added all the positives and negatives. Now what we're going to do is we're doing the next one, which are known as fractions or rational numbers. Anything that can be expressed as a fraction is a rational number. Okay, so that's what we're going to cover. So we'll do basic concepts, like of how to break down fractions and rationals. Then we'll do addition, subtraction, and then I'll get you to do a bit of practice on that. And then we'll do multiplication and the whole rational number system, which is just more and more. Wow, so hey, it's the rules: commutative, associative, and distributive. We're coming back, and closure. Sorry, I grabbed on closure. That's coming at the end where it says the rational number system, so it doesn't disappear. Okay, there we go. We interpret the meaning of any fraction. We must got to agree upon the unit. So how big is this unit, right? Is it square? Is it round? It doesn't make any difference. Is it centimeters? Is it inches? Is it in kilograms? Whatever the fraction. There's lots of parts. Then you have to understand, how are we going to subdivide it into pieces? And you'll see this when we actually look at a fraction, a pictorial representation of a fraction. And then we have to consider, so you take the big fraction, divide it into parts, and then we have to look at what is A, like how much of this fraction is it? So for instance, we have an image, whatever the picture is, B could be 2, and then A could be 1, right? So we're looking at 2 parts of equal size, and we're going to look at one of them. That's what it is, a representation of 1 over 2. Okay, now, when we talk about fractions, there is one big, massive thing that we have to worry about right here. B, or the bottom part, cannot be equal to 0. Does anybody want to tell me why the bottom part of this fraction cannot be equal to 0?
Because then it would just be equal to 1, like the whole thing.
Nope, nope, nope.
Because you can't have
Because-
part of nothing.
Okay, well, okay, now do me a favor. If you have your calculator in front of your phone or whatever it was, do me a favor and just take, let's pick a number, 7 divided by 0. Try to do it on your phone or calculator and tell me what you get.
Error.
An error? What do you mean error? How can you get an error? It's true, you got an error. Right? You cannot divide by 0. It's mathematically impossible. Okay? And we could talk about the logistics behind it, but here's what the deal is. And this is when you're teaching this with kids, and this is when I teach other people too. When you do it, if you're ever unsure of what it is by 0, right? You just punch it into your calculator, you see it doesn't work. And what it has to do is, when we talk about like linear equations, and we're going to get to that when we get to the geometry unit, we're going to talk about slope, right? Like the slope of a house, the slope of a hill, the slope of anything. And it has to do with the slope of perfectly horizontal lines and perfectly vertical lines. And we'll talk about that. You'll see that it'll come back to it. But for now, all you have to realize is when you have a fraction, the bottom part can't be 0. Okay, now, here's the deal. When we're talking about fractions, do we have fancy words for our fractions? What's the top of the fraction called? The
The
numerator. What's the bottom part of the fraction called?
Denominator.
Okay. So when we talk about fractions, again, like anything in math, you should probably use always the same language, right? So you could say the upper part of the fraction or the lower part of the fraction. Now that doesn't make sense. How about the top and the bottom? Yeah, that doesn't work. But if you say the numerator, and the kids and you guys or the kids that you're teaching know what a numerator is, yeah, you know what you're talking about. If you can't remember this, denominator is downstairs. That's how I usually teach it. Denominator, downstairs. It's in the bottom, right? So it's the bottom part of the fraction. Okay, numerator and denominator. So here we go. So what we can do is when we're dealing with fraction, and there are tons of models for fractions, right? There is tons of manipulatives out there, and we'll talk about a few of them when you're dealing with fractions. Okay, so here we go. So if you're going to make a picture of a fraction, for instance, you have a pizza, perfect example of dealing with fractions. Right? You got to figure out what the unit is. What is the whole thing? How many parts are you subdividing it in, which is the denominator? And then how many parts are under consideration, which is the numerator? Okay. So this will make sense in a sec when I show you a picture. So you got to think of the whole thing, the denominator, the numerator, what you divide it into and how many are being considered. So here we go. Let's pick a shape here. There it is. There is our whole thing. That's our whole unit. How many parts is this divided into?
4.
4. So 4 becomes our denominator, right? Because that's our subdivided piece. And on their screen, the one that's shaded in darker, how many of these are shaded in darker? What part of it? 1, right? So our fraction is 1/4. Right? So you got to determine the whole, you got to look at the subdivided parts, and then you got to see the piece we're considering. And the piece we're considering is the dark blue, well, darker blue here. Okay? That's just one shape. This guy, there's our whole thing. It's a big old square or rectangle, whatever it is. You can't really tell. Yeah, looks like a rectangle. How many is this divided into? How many pieces? 12. And how many are under consideration, or how many are shaded?
4.
4. Okay, so then we get our 4/12. Now, don't worry, we're gonna get into reducing fractions later on, right? But at this stage, we're just talking about how to determine them. Okay. Now that's one way to do it when you're dealing with fractions, is you can do shapes like that. When you're dealing with younger kids, they've already learned fractions, but in a different way. So for instance, you can do it as a model, like a subset. So what we got here is we have in total, right? Subset of U of A. Wow, I just said that backwards. Wow. A of U, let's try the thing. U is the universal set. How many apples are in our universal set here? How many apples?
10.
10. That is our universal set. And we are considering the ones with little funny looking worms sticking out of them. And how many do we have sticking out? How many worms do we have sticking out?
3.
3. So there's our fraction. 3 out of 10 apples have worms. Okay. So that's one way. And that usually applies to like younger kids. You'll give them objects and you'll say, okay, here's all the objects. How many objects in total? That's your denominator, right? How many are this color or this shape or whatever it is, whatever you happen to pick. So that's one way. Okay. Another one you can use, and you might have these in your classroom. You might even have them on your wall. They're called fraction strips. Show a thumbs up. Anybody seen fraction strips before? Or anybody use them? Any thumbs? Let's see.
Yeah.
2, I see, 3, 4. Oh yeah, a couple people. Okay, good. So some of you have seen fraction strips before, and you can actually buy them. They're really kind of neat. You just get little strips, and you can make them out of cardstock. In fact, I think I included. I'll have to check on the webpage there. I think I included this activity for you to make them in your school if you want. So if you don't have actual fraction strips, they're pretty easy to make. So here we got our big strip, and if you look, these two strips are the same size, but how we've broken them down, how many subsections, like how many pieces, right? The first one is broken down into 2, right? So that's our denominator. We've shaded in 1. The bottom part, we broke it into 6, and we shaded 3. Well, this is really useful because look, if you look up and down here, the same amount is shaded on the top as it is on the bottom. Now you can talk about reducing fractions or equivalent fractions, right? 3/6 is the same as 1/2. Oh, you can see it visually that they're the same, right? Really kind of useful. Okay. You can also show fractions on a number line. This one is not as useful until you get to high school. We do this more in high school when we're dealing with fractions and properties of them. So if you look at this one, okay, fractions can be divided by subdividing the unit interval. Okay, so look, here's my 0, here's my -1. And if you see, I've broken it down into 4 equal parts. Okay, so that's my denominator. That is my subdividing part. But if you look at the number here, start counting, right? 1, 2, 3, 4, 5, 6, 7. Oh, okay. And it's negative, it's going to the left. So that represents our fraction of -7/4, right? Because we're subdivided into 4 parts, but we go 7 ticks over to the left. Okay. Like I said, that one will be more for high school when you hit it. The ones you'll probably use, right, in middle years are like this method here. Wow. This method here, the subdividing ones, the pictures for the moving stuff, and then the fraction cards. Okay. So let's talk about what you can do to fractions. And and they call it the fundamental law of fractions. And I hate to say it, it is fundamental. Here's the deal. If you take any fraction, don't care what it is, whatever the fraction is, right? Could be an improper fraction, could be a regular fraction, could be a negative fraction, who cares? If you multiply both the numerator and denominator by the same amount, so in this case, whatever n happens to be, as long as n is not 0, remember, because we can't do that because then our denominator would be 0. If you multiply it by any number, you get an equivalent fraction. It's a fundamental law of fractions. Whatever fraction you take. Okay. So for instance, if I had, and here we'll go back. For here, I had 1/2, right? If I times both the numerator and the denominator by 3, I end up with 3/6. Oh yeah, see, it works, right? And this kind of gets into the basis of when you have to add fractions, when you got to find common denominators and stuff like that. That's where we're going to get into that with this. Okay. So that's, oh, there it is there. Now, when you have fractions and you want to compare them to see if they are equivalent, right? There's a fast way to do it, right? It's called cross multiplication. Do you remember that? You guys remember the term cross multiplication? It means you multiply on the diagonal. So if you look, hey, look here. So we have A over B and C over D. So if I want to find out if they're equivalent, I take A times D and I multiply them together. There's my A and D. And I take B and C and multiply them together. And if they are equal to each other, those fractions are equivalent. Okay, you guys know what I'm talking about, or do you need an example? You guys know what I'm talking? Okay, you guys know what I'm talking. And don't hesitate. Like if I say, hey, do you need an example? Say, oh yeah, I need an example. Doesn't mean you don't know what you're doing. It just you might need a refresher. Okay. Now, reducing fractions. Every time we talk about fractions, we often try to put them in their lowest form, right, or simplest form. So here we go. We have 28 over 48. That's not in lowest form. So what you're looking for is, I'm looking for a number that I can divide out of the top, but that number also has to be divided out of the bottom, right? Because you're talking about multiplication. Remember, that was one of the rules. So for instance, 28 and 48, they're both ends in 8, they're both even numbers. Would 2 work? Yes. Is there a bigger one that works into both? 4. 4 goes into both. So what we can do is we can break this down into this, right? 7 times 4 is 28, awesome. 12 times 4 is 48, awesome. Now here's the deal. Look at this part here. Do you see the 4 over 4? What is any number divided by itself?
1.
1. So technically, that is 7 over 12 times 1. Okay, so do we even need the 4s anymore? Do they reduce out? They reduce out. They don't cancel each other, they reduce. Canceling means 0. Reduction means 1. It's a technicality, but it's very important. So we end up with 7 over 12. Okay, now I want to show you a little shortcut. But this, you have to understand how to reduce fractions. Grab your calculator. And I do not know if this works on your phone, because I don't know if your phone has that ability. On your calculator, look for a button that is A, B/C. It's called the ABC button. Okay? If you have a calculator, look for it and see if you find it. Tell me if you find the ABC button. And those that are like use their calculator, their phones as calculators, you can try it, but I don't think it works. So you'll be at a disadvantage when we do this shortcut ways. Okay, if you have it on your calculator, this is what I want you to type in. 28 ABC, at whatever that button is, 48, and then hit equals. And tell me what you get. Anybody that has, tell me what you get.
7 over 12.
Yeah. Did it reduce the fraction?
Yeah.
And it actually looks on your screen, it'll look a little different. It'll look like a 7, like a little R sometimes, or a backwards R, just or a little mark, and 12. But that means just division. That means just a fraction. So for instance, if I gave you any fraction, you can quickly check with that ABC button, right? To figure out if it's can be reduced. It's kind of a useful one. Now, do you still have to know how to reduce it manually? Well, of course, but this is to speed it up when you're actually looking for stuff. Okay, so fractions in its simplest form, you can do it algebraic or mathematically like this, but you can also do it with pictures. So for instance, find the equivalent fractions to 5/6 and 1/4. Okay, so here's 5 over 6. You can see it's broken down into 6 subsets, and we've highlighted 5 of them, right? So that's 5 over 6. Well, the cool thing is if we want to find an equivalent fraction, the width of this, the 6 is still the same. But what we can do is there's the quarter, sorry, there's the quarter, right? So this bottom one, if you look, we can break this bottom one down into 12 sections instead of 6, because that's our common denominator. It's 12. So what we did is we just then took our 5/6 and drew a line on every single one of these. Now, the interesting part is the shading is still the same. You can't make more shading or less shading. So in this part, you can see it's exactly shaded the same. But when we count these, right, we got 12 in total, our denominator, and we've shaded 10 of them. Oh, okay. So 5/6 is equivalent to 10/12. Yeah? What about a quarter? We break this down in a quarter. We got to break it down into 12s again. You can see we break it down into 12s, but this one we only shade 3/12, right? Because that's the part that matches above it. Does that make sense? Hopefully. Okay, now, oh, sorry, go ahead.
Brian, do you mind just going through that ABC problem again? I just want to try that on my.
Oh, okay. Do you have an ABC button on your calculator?
I do, yeah.
Okay, so let's do the one that's on the screen here. Let's put in, so what you're going to do on your calculator, type 10, ABC 12, right? So 10, the ABC button 12, and then hit equal, and you should get, if we look, we should get 5/6.
Yeah, that works out. Looks like, yeah.
And it's really useful, especially if you have like a really big fraction. Let's say like 1,024 over 20,000, something big like that. It'll help you reduce it. Now, it will also do improper fractions. Remember, improper is when the numerator is larger than the denominator. It'll handle that also. So it's kind of useful. Okay, so you can also represent, we did those mathematically. You can also do those, no, sorry, we just did those with pictures. Sorry. Rational numbers. Okay, now, you got to remember what we talked about. Natural numbers, 1, 2, 3, 4, 5. Remember, they start at 1. Then we added the 0, which was whole numbers. Then we added the negatives, which is integers. Now we're doing rationals. This is anything that can be expressed as a fraction as long as the denominator, or in this case b, is not equal to 0, because you cannot do that. Okay, so let's look at this here. Let's look at this next page. Two rationals are equal only if they're represented by equivalent fractions. So what we're going to do is we're going to look at a whole bunch of rational numbers, and we're going to see if they're equivalent. Okay, here we go. Here is a list of rational numbers. Okay, we got 2/5. Perfect. It's expressed as a fraction. Uh-oh. Uh-oh. What about 3? Is 3 a rational number?
It's equal to 39/13.
Oh, hang on. Quick jumping the gun. No, but here's the deal. Is 3 by itself a rational number? That's what I want to know.
Yes.
But it can be expressed as a fraction, correct?
Yep. 3/1.
3 over what? Say that again, sorry.
3/1.
3/1. Excellent. That's the point I wanted to get across. If you have a number just like 3, it can be expressed as a fraction, which is 3/1. That does not change the value of 3. It's still 3. Okay, perfect. Now, what we're looking for is equivalent fractions. So do the one you just said before. We'll explain why. Who was that? Was that? I can't remember who said that before.
Me.
Who's me again? Where are you? Sorry.
Eric.
Oh, thank you, Eric. Thank you, Eric. Okay, so tell me what you said before. The 39 part.
39/13 equals 3.
Okay, how do you know that?
I cheated with my calculator.
No, you didn't cheat with your calculator. You did something smart with your calculator. Okay. Now, watch. I want to show you something. Let me stop sharing this for 1 sec. Let me throw up my smart board. I want to show you something. This comes back to that rule, that cross multiplication rule. I want to show you something. You tell me if it works. Sorry. Here, let me turn my microphone around. I can't put it on my head because. Can you still hear me even if I'm talking from here? Can you still hear me?
Sort of.
It's a little bit quieter, is that correct?
Yes, but you're
Okay, just give me, I won't be up here long. It's just like I said with the headset. Okay, so 3 is over 1, right? And what was the other one you said? Was 39 over 13, right? Okay, here's the deal. You can check to see if those are equivalent by multiplying, by cross multiplying. So let's do this. So what I want to do is I want to multiply those together. 1 times 39. And I want to multiply these together. 3 times 13. Okay? 1 times 39 is 39. 3 times 13 is 39. So, according to Eric, and he's right, those two fractions are equivalent. That's a fast way of doing it. And like Eric did, like he just used his calculator and used the ABC button. That works also. That's nothing wrong with that either. Okay? But that's that cross multiplication I was telling you. Okay, now, is there another set here that are the same? I gotta stop sharing the screen here. A sec. This. Share screen. Okay, so 3 and 39 over 13. What's another one?
2 over 5 and -4 over -10.
Okay, well, here's the deal. Would you ever write -4 over -10? Would you ever write double negatives there?
No, but you
No.
did, so
Well, no, I know, I was trying to make a point. Okay,
Okay.
so a negative divided by a negative is a positive. So this 4 over 10 is actually positive, right? And if you took the 2 and multiplied it by 2, you get that one. If you took the 5 and multiplied it by 2, you'd get that one. You're right. You're absolutely right. So let's look at these here. So there they are there. So 2 over 5 is the same as -4 over -10, which you would normally write as 4 over 10. And 3 over 1 equals 39 over 13. We know those ones. And then all the other ones, the 2/5, and the 3 different rationals are 2/5, 3, and 7/4, because those are all different from each other. Okay. So those are how you tell for equivalent fractions. Okay, so let's get on to adding fractions, because adding fractions is so much fun. So let's add some fractions. Woo! There we go. Okay. When you have fractions and you want to add them, you have to have a common denominator. So the denominator, or the part downstairs, has to be exactly the same. Then all you do is take the numerators and add them. The biggest mistake students will make is they will add the tops, the numerators, and they will add the bottoms, the denominators. And that's the biggest mistake that students will make when they do addition and even subtraction too. Super common. Okay, so let's look at an example here. And here's the key thing. They have to have common denominators. And if they don't, then we're going to make them. So here's our big circle, the first one, the blue one. It's broken down into 8. We have 3 shaded. So we have 3 over 8, right? And our green one, it's broken down into 8. We have 2 shaded. So that's 2 over 8. Now, since we are adding them together, all we're going to do is add the shaded parts, or the numerators. So 3 plus 2 is 5. And then our denominators stay the same. Don't make that a 16. That's not what we're doing. The denominator stays as an 8. So then we have in 5/8 shaded. Okay? You have to teach fractions. You'll have to get used to this. Okay. Now, that method works really well because it's a visual method. You can also do this. Okay, I'm going to show you a bunch of different methods here. You're going to find some of them will work with your students. Some of them may not. Some of them you might like better than others. So the next one is to do it with a good old number line. Now, the problem with this one is your number line has to be broken down into, look, it has to be broken down into 8s, right? Oh boy. So instead of like going 0, 1, 2, 3, 4, 5, it's 0, 1/8, 2/8, 3/8, right? Process is still the same. We have our 3/8 here, our blue one. And then we go another 2/8. And then we look where we end up. Oh yeah, we end up with 5/8. It works, but the fractions on the number line might be a little confusing for some of your students. Okay. Now this is a neat one, and it's kind of tricky to look at when we oh, this is unlike ones. Okay, never mind. Modeling addition fractions with unlike denominators. Okay, so unlike is something like this. And when you do this, you might when you're teaching it, you might do it graph or pictorially like this, but you might go right into doing it algebraically, which is the most common way to do it, which we're going to do in some practice coming up here. The problem with this one is, look, we got a 1/4 that's broken into 4s, but this one's broken into 3s. Yikes. What happens here is, if you look, you see how we offset it, because basically we're going to take all of this blue stuff from 1/4 and all of this blue stuff from 2/3 and add them together. The only problem is we don't have a common denominator. Now, can anybody see, and you should be able to see this because you've done fractions before, can we break this 4 down into something and this 3 down into something so they both have common denominators?
12.
12, okay. Still, and we'll talk about that coming up, like how do you do that? So what we can do is we can break the 1/4 down into 12, right? There it is there, broken down into 12. The shading is still the same, so we have 3/12. The 2/3 can be broken down into 12, but the shading is 8 of it. And then we add those pieces together. You can see I got 3 here and I got 8 here. So my bottom one is 11 out of 12. So that is a visual demonstration of how to do it with unlike denominators, but eventually you're going to be teaching it. You're going to multiply both the top and the bottom by 3, both the top and the bottom by 4, right? That's the more common way to do it. Okay. Now, all those numbers we've been dealing with so far are proper fractions. And when I say proper fractions, I'm talking about the numerator is smaller than the denominator, but that's not always the case, right? If you ever do a baking recipe and you got 1.5 cups of flour or 1.5 cups of water, right? You have a mixed fraction, which can be turned into an improper. Now, do you remember your weight? Do you remember your rules for doing this? Right? A mixed fraction has a whole number in the front and then a fraction behind it.
You multiplies the whole number by the denominator and then add it to the numerator.
Perfect. Okay. Now, this, I'm going to show you this and then I'm going to show you an easier way. So this basically, you have to multiply A and C and then add B, but C doesn't change, right? So what Lacey just said, you take C, right? Multiply it by A and then add B.
Right.
So Chris, sorry, go ahead.
I missed one sentence. What are you trying to do with the mixed fraction?
You're trying to change it back to an improper fraction. I'll show you in the example coming up right here. So here, and then you end up with AC plus B over C. So let's look at an example here. So that right now is a mixed fraction. I got 3 wholes and I got 2/5 of a fraction. I want to turn this to a improper fraction, which means the numerator is larger than the denominator. So you take 3 times 5, right? 3 times 5 and you add 2 to it. So 3 times 5 is 15, plus 2 is 17, and you end up with 17 over 5, right? That's really, really common. Is this coming back for some of you? Okay. Okay. Here's the way I show kids. And this is the way, it's the same process, but it's a little bit, I find smoother, I think is the better. Here, let me close that one. Put this one up, share screen. I'm running up to the board again, so I'll turn my microphone around, but it'll be a little quiet. I'll try to talk loud. Actually, that's not a problem. Anybody that's ever met me in real life, they quite loud. Okay, so what was that? 3? What was the number again? Somebody tell me.
3 and 2/5. 2/5.
Okay, this is the way I do it. It's kind of a refined way, and this is probably the way you learned it at one time. The 5 and the 3, you multiply, and then you add 2. Right? You can see it. It's like a pattern on the screen. So let's do this. You do this in our head. 5 times 3 is 15, plus 2 is 17 over whatever the denominator was. By show of little thumbs there, how many people have seen that method before? Or is that the way you normally do it? Okay. Yeah. You'll see that that's another way to do it. That's the way I learned it at one time, so that's why I'm sharing it. It's basically what we just did mathematically, but it's a little faster way to do it. Okay, so let's take a look at this. Here, let me stop sharing. Sorry. Let's back up. Man, flipping back and forth between screens is just annoying. It's really annoying for you guys too. From the current slide, there we go. Okay, so, oh, we just did that one. Okay, now you can also do, look at this pictorially. So the top one, we have 2 whole ones and 3/4 of the one on the right. Well, we can also show that if we break every single square up into quarters, right? We shade the first one, shade the second one, and 3 of these are shaded. So we just count the shaded parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 11/4. Right? So you can see those are equivalent fractions. The first one is mixed and the second one is improper. Right? When you want to show kids that. Okay, here's what I want you to do on the next one, because I don't think it's. There it is on your screen. 3 and 17/120. What I want you to do, and you can do this with your calculator, I don't care. You got to still be able to know how to do it. I want you to change it to an improper fraction. So the method I just had up on the board before with the little arrows, that works. You can do anything you want. Just take a minute to do that. We'll see. We're almost done. We got like 2 more slides and then we're going to do a bit of practice. And then we'll take our break after that.
377/120.
Okay. So what did you do, Alice? Tell me your steps.
120 times 3 plus 17.
Perfect. So yeah, right. The 120, right? I don't like the way here it is. 3 times 120 plus 17/120. You know, sometimes the way that the Americans do stuff, because this is an American book and everything, sometimes the way the Americans do stuff is convoluted. I always prefer the simpler method, right? So 120 times 3, right? There's our 120 times 3 plus our, they did it as 17, right? 1 times 17 over the 120. We end up with 360, and then we end up with a 377. Okay. Now, that is going from a mixed to an improper. Let's go the other way. Let's ignore those 113s on the bottom of the screen. I had to fix the slide because it was wrong. We want to go from an improper to a mixed. Oh, so we want to go with some whole numbers and a fraction left over. Okay. So what do you think the method for this one is? Somebody want to take a guess? The method, how we do it?
Division.
Division, correct.
355 divided by 113.
Okay, now, if 113 went into 355 evenly, like no remainders left over, great. So this one doesn't. So what you got to do is you got to try to find how many times 113 goes into then that numerator number evenly, and then whatever's left over is our fraction. So how many times do you think 113 goes into 355 evenly? Like, nice number.
3.
It goes in 3, right? Okay. So if you look at this, we got 355 over 113. That's the same as 3 times 113, right? And 3 times, what is it here? 3 times, well, that's the divide. Oh, I got the wrong buttons here. 3 times 113 gives us our 339. Oh, okay, that's getting close. And then what do we have to do? Add another 16. Yeah, that gets us to our 355. Okay. So what we've done is we've broken the whole numerator down into something that makes sense. 3 times 113 is a perfect one, right? Because we get to do it 3 times. So our fraction then, if we want to change it to mixed, is 3 and 16 over 113. And if you were unsure about that, could you check? Yeah, 113 times 3 plus 16. Now, here's the deal. If you try this on your calculator if you want. 355 ABC 113 hit equals, and you're going to get something that represents 3 and 16 over 113. Try it and tell me if you get it. It's going to have those little symbols between it, but that's basically division is what it is. Did you guys get? Brooke got that. Awesome. Anybody? It looks a little different on your calculator screen, but it still represents the same thing. Okay. So let's talk about let's talk about just subtraction before we do this one. In subtraction, subtraction of common denominators is the same. It's the same as addition. If you have common denominators with subtraction, you just subtract the numerators. But the problem is when you have different denominators. So let's look at this pictorial example here. So that top strip, what is the fraction for that top strip?
5, 6.
5, 6. What's the fraction for the strip underneath it?
1, 4.
Okay, now the problem is those aren't common denominators, are they? Crap, that doesn't work.
Yep.
So what we can do is if you look, you see what we're doing is we're trying to take this 1/4 off of this chunk here. So you can see underneath there what we're left with. We're left with this strip here of just the blue stuff. Well, the problem is since we don't have a common denominator, we have to find one. So we have a 6 and we have a 4. What is our common denominator? What are we going to break this bottom piece up into?
12.
12, right? And you can do that. And that's one of the things we can talk about is you got the 6 and the quarter. So we break it up into 12s, right? This piece here, this 1, 2, 3 on the top part here is the same as that. So that's gone. And so how much is left over? 1, 2, 3, 4, 5, 6, 7 out of 12. So you can see when we
Come
look.
up with 12.
Sorry, what was that?
How do you come up with 12?
How did I come up with 12?
Yeah.
Okay, so if you look at this top one here, right, it's broken into 6 and the bottom one is broken into 4. We need to break these rectangles down so they're exactly the same in the top and the bottom. So for instance, if you can see with the mouse here, if I draw a line there and draw a line there and draw a line there and there and there and there, I can break that to 12. This bottom one, I'm going to have to break down into equal parts of 3, right? So they have to be the same size. So if you look at this one, I can go here and then I can go here. This is pictorially. If you were to do it mathematically, you would just multiply both the top and the bottom by 2 for the 6, right? And both the bottom, top and bottom by 3 for the 4s, for the 1/4. Okay?
Makes sense. Thanks.
It's this way is a kind of an interesting way with the strips, but it's actually a really nice visual way to see subtraction. It'll also help kids then start finding common denominators, which we're going to talk about. You need to be able to find common denominators. Okay? Okay, so now that is, so 5, 6, sorry, minus a quarter equals our 7 over 12. Okay, so now what I want you to do, take 10, 15 minutes and we're going to do some of these questions here. So let's look at 6.1. Here, let me put my book. And 6.1. Which ones are we doing here? 1, 2, 5, 7. 1. Yeah, you can do that. 5. Yeah. Yeah, these are all kind of shapes. 10. Where do we fit to the actual work? Let's see, 14 is actual work. 23, 24. Yeah, that's actual work. It's fine. Okay. So take 10 or 15 minutes to do that. Who was it again? I think it was. Who was having trouble with Genius Scan? Was that, who was that I was talking to before?
I think that was Lori.
Was it Lori? Lori, was it you? Where are you on here? Lori, was it? Yeah, yeah, you're right. Lori, you were having trouble with Genius Scan, is that correct?
Oh, that was me. Yeah. I gotta log off for now. So download it.
Perfect. So yeah, log out of Zoom because you can always come back in. Like we're not going anywhere without you. So yeah, log out of Zoom
Okay.
and download Genius Scan and then come back in.
Okay. Thank you.
Okay. And I will be right back. Just do those questions. I'll be right back. gonna try to fix my headset. Let's see if I can. Seems to work. You guys still hear me?
Yep.
Okay, good. Thank you. You could do that as a joke when I ask that question and nobody answers. Then I'm like, you could really play a joke on me, couldn't you?
So I have a question for number 29 on the assignment.
29 on the assignment. Give me one sec. I could play a joke on you. What are you talking about? There's only 25 questions on the assignments. Yeah, I could play a joke on you. I'm just joking. Give me a sec here. 29 on the assignments.
That would start a war.
Okay, go ahead. Ask away.
Okay, so only the numbers are absolute. The answer will not be absolute in this, will it?
Oh, you mean like you're talking about positive?
Yep.
No, the answer in this case, because the thing is when you take the negative 16 and do the absolute value of it, it changes it to 16, right? Same with the negative 13 minus the 8, but you still have a negative subtracting something else. You're going to end up with a negative as an answer is what you're going to do. Anytime you do the absolute value part of it is always positive, but you could still end up with a negative depending on the signs that are in front of it.
Yeah, that's what I meant. The numbers themselves are absolute value, but the equation itself is not.
Yes. There you go. You got it.
I have a question about assignment 3. The
Hang on. I do not even have that one out. So give me one
Okay.
sec. Assignment 1. Okay, I got 3. Go ahead.
So it says use the figures to answer this question, and then it says list the 4 figures of equivalent fractions shown.
Okay.
So 4 of these figures are going to be equivalent to each other, or there's going to be 4 different pairs of
No, just 4.
equivalent?
So list the 4 figures of equivalent fractions. Oh, wait. Oh, I see what it's asking. Oh, hang on.
But I think there's 5. I have the same question.
Let's see. That one's the same as that one. Okay. That one is the same as that one. That one and one, hang on. 1, 2, 3. Oh, that's different. Those 2 are the same. Yeah, so look for the pairs. Like for instance, one of the equivalent fractions is 1 and 2, right?
Yeah.
Yeah, so just list that. So you put 1 and 2. That's all you need to put.
So there's going to be 4 different.
Yeah, 4 different ones, and there's quite a. There actually, I think you're right. There's more than there.
Yeah, there's
Yeah,
a lot of.
but just
that could
put
be
4.
equivalent to each
It's kind of
other.
like on. It's kind of like what I did when I was marking the current assignments. The one question where there was all those. Remember the absolute value of x and absolute value of y. There was
Yeah.
actually, I think, 12 combinations. But if you put 6, I gave you the full mark for it because there is a lot, right?
Yeah.
But I did that for everybody, just so that'll be the case. So if there's 4 and there's more than that, then I'll just give you the marks based on that. So.
What about for question 1? 7/11 is already at its lowest value, so it can't be equivalent to 4/8 because
Okay.
if you multiply.
But there's multiple ways to show me that, right? You could find common denominators, right? That's one way. Or could you just do that method that I had on the board before this one here? Hang on. Give me 1 sec. 1 sec, 1 sec. Share screen. This one here. This is a great way to show for equivalent fractions. Just cross multiply. Right?
So when I tried to do that, and when I cross multiplied it, I had 44/56.
No, you don't get 44/56. Look what you get. You would get 44
Okay.
equal to 56, and then you would do this to it. You would go, right?
Oh, okay, I see.
Does that make
I
sense?
understand. Yeah.
Because all you're doing is you're comparing to see whether they're equivalent or not. In this case, the example that I have on the screen right now, those are equivalent, but yours won't be. But there's multiple ways to show me that they're not equivalent, right?
So for that one, I just put like 4/8 divided by 4 on both sides, and then it reduces to 1/2. Or when you multiply it by 2, you get 8/16. So there's no way to make it. You can't get a denominator of 11 with
No,
4
but
eighths.
I do. Okay, do the whole thing with a common denominator. What would the common denominator be in this case if you had those two fractions?
Oh, okay, never mind. I see what you mean.
88, right?
Yeah.
Do it that way, and then you can show that they're not equivalent. There's, like I said, there's lots of ways.
Yeah. Okay.
I need to remove that one. What time is it here? We are. How much time did I give you? Was that 10 minutes so far? When did we stop? Was it 10 after? I think so. we still got to take a break in there. So for those that are working away, you can keep working if you want. For the rest of you or whoever wants to, take your break in here too. So we'll take a break and we'll come back at jeepers. You only need what, a 10-minute break. You don't need 15. Let's try coming back at 25-2. The reason for it, I want to do the multiplication and give you some more time to work on questions. So take your break now or keep working, but at 25-2, so 10 minutes from now or so, we'll start up again doing 6-3 and 6-4. We don't need that. Okay. Oops. Hey Sam, is that buzzing still there or is it gone now? Because I'm not muted right now, but is that buzzing still there? Oh, you might have left already. I don't know. Okay.
Sounds good now.
Okay.
Yeah, the buzzing is gone.
Well, it was buzzing before. I wonder if it's because I was plugged in. Maybe that's why.
Maybe.
Yeah.
Okay. Okay, sorry about that. I mean, technology.
We learn to adapt, Brian.
Yeah. You'll be a teacher then. That's all teachers is sometimes, adapting on the fly.
Hey Brian, we got a presentation from one of the authors of One-Eyed Jack's Boxcars and One-Eyed Jacks.
What?
Today. He came in and talked to us.
Where was
And,
that? I don't.
Sandy, for Math Methods for Sandy Margetts.
Oh. Have you told Sandy that I'm teaching you?
Yeah, we were talking about you. She's like, "Oh, I taught him. I remember him."
And Sandy is one of my favorite people in this world. So.
Yeah, and then we had Skinner popped in too. He
Oh,
wanted to learn some
jeez.
math.
Oh my God, Tom Skinner. Oh, he's an interesting one.
Yeah, he's a great guy, funny guy.
After taking courses with him, I realized that teaching is all about getting sued. That's kind of the joke with him, right?
Oh
No
my
matter
God,
what,
that's so funny. I did the same thing.
makes you
He
stop
tried
wanting
to
to
convince
teach.
me to start a union for the EAs.
Oh, Tom is a great guy. Yeah, that's so cool that you had Boxcars and One-Eyed Jacks. It's still and I'm teaching high school and I've been doing it for 18 years now. It's still my go-to book.
Yeah, and he's a really funny guy. He would have give you a run for your money with the jokes.
Oh, my jokes are horrible. Oh my God. My jokes are bad.
He made Dr. Evil jokes, so he started it out good.
Those always work.
Yeah.
I see that, Lori. I see your message there. I can't remember how to direct message here. How do you direct message? Oh, there it is. There it is. Okay, never mind. I see that. Okay. Oh yeah, I wanted to double check because we're still missing some people from before. I wanted to see if they signed on. Let's see. Do that. Who was it? It was Kayla George. Did Kayla ever end up signing on? Let me look.
I have a quick question then.
Hang on one sec, Alice. Kayla, I'm just looking to make sure I don't miss anybody on the thing here. And the other one was Farah. Did Farah end up signing on? Farah Mead. I don't think so. I think those are the only two. Go ahead, Alice. What was your, sorry, Alice, what was your question? There you go.
Page 277 in the book.
For question 77?
Page 277 in the book, question 10.
Question 10 to, oh, yeah, okay.
What is C? It's not half.
Let me draw in my book here and let's find out. 1, 2, 3, 4, 5. 1, 2, 3, 4. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 11? No, I don't see 11. Ooh, that's a tough one because you gotta break it down into its pieces, eh?
And it doesn't say anything at the answer piece.
So that would be A looks like it was 1/3.
B is 2/3, I think. Oh, 3/4.
No, yeah, 3/4, 3/4. Yeah, that's B. So this one would be maybe 6/13. No, because 7 is the other direction. 17/20. No, it's a little bit bigger than a half. I'm thinking it might be 17/30, but I would never give you a question like that where you had to break it down. But if you look, it looks like it's just a bit over half, right? So I'm thinking 17/30, right? Because 15/30 would be half. I'm thinking it's 17/30.
Okay, thanks.
And then the other one, the D looks like it's just below half, so that might be 6/13. That's what the one I would think that would be 6/13.
Oh, I figured D is half. Actually, yes, it's not quite half.
Okay.
I have a question about assignment 3, question 4.
Hang on, I put it away. Next, you got to tell me, don't put it away. I'm joking.
No,
That's not where I want to go. Hang on. It's a good thing I'm organized. Assignment 1, assignment 3. There goes my paperclip. Which question, sorry?
Number 4.
Number 4.
Just curious, when you're writing the answer, do you want us to just give the number of the figures, or do you want us to actually show you the fractions that we're representing?
You can give me the number. You can just give me the number of the figures. But if you want to show the fractions, hey, I mean, it shows that you know what you're doing. There's nothing wrong with that. Yeah, just you can just put the figures if you want.
Okay. And if we were to represent, let's say I'm writing the fractions and then reducing them, if I show you the fractions as the reduced fraction, that's okay? All right. Just wanted to check.
Can I ask a question about the textbook questions we're doing right now, please?
Of course.
So it's question 22D.
On which one?
Page 278.
278. 22D. Okay, go ahead.
Oh, that wasn't even one that you asked us to do. I looked at the wrong number. But anyways, let's pretend that you did, because I'm doing it anyways, apparently.
Okay.
It's finding the equivalent, and it's 1/25 and -3/500. And I forget how to do it with negatives on 1/2. So could you review that maybe?
You can still have all you would do in that case is you would multiply by, well, okay, ignore the negative for a sec.
Okay.
And what would your common denominator be?
500.
So you'd end up with -3/500.
And 4/500.
And 4/500. So for each of these set of fractions, determine equivalent fractions with the common denominator. So those are the only difference is you would have to either multiply one of them by a negative, either one. So then you would make, so you take, let's say -3 over 500 and you would times it by -1. That would make it +3 over 500. Right?
Okay.
And then that's all it's kind of a silly question in that you don't normally do that with negatives. You don't normally make a positive and negative equivalent fractions. You just don't do that.
Yeah, okay. I thought it was kind of weird, but
It
then
is
I was
kinda weird.
like, maybe I'm wrong. Okay,
Nope,
cool.
nope,
Well,
you're fine.
turns out you didn't ask us to do it anyways, so I'm just doing extra work.
Good. You know what? Oh yeah, Lacey. Lacey, I'm going to assign you questions 1 through.
All right, enough. I'm already teaching online and studying.
52.
online.
1 through
Give me a
52. Let's go.
break. At least I just taught fractions last month, so.
Oh, good. How did you? Here's a question. How did you teach it?
The way I explained to you how to multiply them.
Okay.
I don't know. I hate number lines. They're annoying.
It's a tough one. Here, let me show you something. Yeah, you can see my screen. If you have a chance to go back, I mean, this is the folded fraction activity, right? This is the one where you take the construction paper and you fold it and you break it down into half, a quarter, eighths, right, like that, and you can use that. And there's games you can play with them. And I think I don't know if I linked the game, so I don't think I did in this case. But here's a really interesting one. It's called the Fun Fractions website, and what it is you can deal with fractions like this, and you will probably have these shapes in your school.
Yeah, I actually used this in my math methods class.
With Sandy, yeah, that's probably, I think
No.
that's where we did it before, right? So you can break it down, right? These ones spin around.
I
Right?
took it with Candy Skyhar.
Oh,
yeah.
oh, good old Candy. Yeah, okay.
He was great.
No, I've known Candy for years. I know her husband Wayne really well. So anyways, so you can see that there's a fraction, there's a half of it, right? So you can do that. That's one of the ones. And there's, I think I list on here, where's the activities? So this is really cool. You can give kids these ones. How many green triangles are in one blue rhombus, right? So then you can give them the shapes and then they can deal with the fractions on the side. These are kind of fun ones to do. And this one, this is a great, I don't know if you ever have played Who Has. Who Has is an amazing game.
Yes, I played this with Candy actually.
Okay, so this one you can print off if you want. It's full fractions, right?
But we did this with multiplication circle. It was going to be my activity with you, so don't do it.
Okay, I won't.
Thanks. You're going to do it until like Monday now, just to spite me.
Pretty much. No, I won't. So, no,
That's
this was
fair.
this is one of the activities I was just going to point out today. One of these Who Has. I guarantee you I'm probably going to get a couple of them at the end of this course, because everybody always does them because they're so good. But you can do them anyway. Addition, subtraction, multiplication, division. You can do anything you want with them. They're awesome.
Yeah, it was great. Cool.
Okay.
Yeah, it's tricky because there's no manipulatives right now, so it's.
Yeah. Well, see, and where Sandy normally teaches out of, which is where the room I teach out of, down in the Pent office, or across from the Pent office, is all the manipulatives. Everything is there.
Yeah, well, we're learning how to teach online, but then you go to the schools and they don't have enough computers, so it's a little bit futile.
Yeah, a lot of the schools are trying to go to like iPads and stuff like that, but I mean, again, you're limited by what you have access to, right?
Exactly. So
it's the problem with this COVID and this whole remote learning. It's just not an equitable situation for most people, and that's an issue. So I mean, that's why with you guys, at least I know you're online, so you have access to a computer. That's why I've included a lot of websites that are related to. This is a great one. This, like, here, there's your one, there's your half. This is folded fractions, right?
yeah.
Makes
Yeah,
a
we
weird
used
sound.
this toy theater one and the one you did the other day with like the centième, millième, dixième. The mats and sheets. Sorry, I teach it.
Oh yeah.
Like the sheets and the units and the strap.
Place value cards. No, that was Tarzia. Oh, wherever it is, it's somewhere in here.
Yeah, the one you did the other day. Anyways, I was like, I've known a couple of them already, which is great because it's handy to have.
Yeah, and I'm like, this website doesn't go down. This website will be here permanently. So if you're doing something you can't remember where it was, just go here and you can probably find the link on one of my activities. Oh, okay. Oh, crap. Okay, let's get on to running out of time here. Man, look at that. Lacey distracted me and I keep talking away and I'm struggling.
Can I ask a quick question?
Yeah, go ahead, Alice.
On question 23 on page 277, is there a shortcut way of doing this?
23, you said?
Yes. It's finding least common denominators, and I'm on question B. And I've been fiddling around with it for 5 minutes. I wonder if there's a...
So you have a 7, a 5, and a 3. Okay. So what you can talk about, you can teach kids this too, is sometimes they're not always going to find the lowest common denominator, right? But what you can do is if you take 7 and 5 and 3 and multiply them together, that number will always work. It might not be the lowest, but it will work. So you might have to reduce something in the end, right? So what do we got there? Where are we? 7 times 3, 21 times 5 is 105. So 105 will work, but it might not be the lowest. Does that make sense?
Yes, perfect.
Okay, so let's stop sharing this. Let's go back up to the PowerPoint. Let's do some multiplication and division because it's so much fun. Share screen. This one, share. Okay. Multiplication and division of fractions. Okay, I'll speed this up a bit. Just because we'll get to the rules and then we'll actually get to the work, which is what everybody wants to see. Okay, so if you take multiplying fractions and dividing fractions is way easier than adding and subtracting. It just is. And so but you teach adding and subtracting first, and then you'll switch to the multiplication. When you're multiplying fractions, the key to it is you multiply. You don't cross multiply, you multiply straight across. Okay, so remember what cross multiplication was A times D, right? And B times C. When you're dealing with multiplication, you multiply straight across. So you multiply the numerators, A times C, bang. You multiply the denominators, B times D, bang. And then you reduce it after that. So multiplication is quite a bit easier. Now, I'm going to show you when we're going to do the picture one, and then I'm skipping over the number line one. Because I was looking it over and it's just silly. I need to take it out. I've actually put a note in myself to take it out next year. Here we go. So 5/8 times 2/3. Now, once you get to the next stage, you'll know right away, oh yeah, 10 over 24, right? You just teach them that. But if you're trying to show them pictorially, this is one way to do it. Now, careful with this one. Here we go. So what we have here is if you look at this first column, right? The first column is broken into 8, and the green part here, this one, this one, this one, this one, there's our 5/8 right there. Okay, then we look this way and we look on the horizontal. We break this into 3 parts, and we see our green part is 2/3. Okay, now if you look, all of this here is the shaded part, right? And how much is shaded here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our 10. There's our numerator, our 5 times 2. And then how do we get the denominator? Well, that's the whole other part of it that it's all subdivided into. And it's subdivided into 24 parts, right? Now, that way, this way I'm showing you here only works for certain kids. Certain kids are going to look at that and they're not understand it, right? Some of you might look at that and not understand it. Some of you might like, oh yeah, that actually makes sense. It's an interesting way to show fractions. Again, it will depend on you and it'll depend on your kids. But really what you're trying to do, probably the easiest method, is just to multiply straight across, right? 5 times 2 is 10, 8 times 3 is 24, just like here. Oops, just like that. This product method is probably the easiest way. It might not work with a visual representation, okay? So that's that one. Now, the next slide, we're just skipping over. I realize I'm taking it out. So then, yeah, skip that and let's just this. Okay, multiplication straight across. Now, what about division? Division is just like multiplication. There's only one difference. A over B divided by C over D. Here's the deal. When you divide, it's the same as multiplying by the reciprocal. Okay, so you might have to know some, yeah, you might have to know some terms. Reciprocal is where you take the numerator and denominator and flip them. Okay, so if you look here, we took our C and our D and we flipped them to D over C. And again, then you just multiply straight across. Now, the biggest mistake people make, the biggest mistake students make is they flip the front one instead of the second one. They flip the first one instead of the second. The only one you flip is the second one. Okay. So basically, right, that's just a way to take division and turn it into multiplication. And this process for dividing is not a definition of division. It's just a procedure to do it. Okay, so let's do an example here. Where'd the first one go? There's the first one. Okay, there's the first one. 3 over 4 divided by 1 over 8. So it's a division question. I need to turn it into a multiplication question. So which one am I going to do the reciprocal of? The first one or the second one?
Second.
Second one. So I'm going to get 3/4, right, times 8 over 1. And then you can do the multiplication. 3 times 4 equals 24. 4 times 1 equals 4. And that equals 6.
Why 8 over 1?
Because it's the reciprocal. We take the numerator and the denominator and just flip them on the second one. That's all we do. It's just a process. Now, some of you then can move on to the next step with your kids, and you might remember this. Like this one, we just multiplied straight. 3 times 8, 24, 4 times 1. Some of you might have learned about how to reduce, reduce on the diagonal. Do you know what I'm talking about? 4 goes into 4 once, 4 goes into 4 2 times, and then you just end up with your 3 times 2 gets you your 6, right? Some of you might remember that. If you don't get it, it's not a big deal. Some of the kids that you teach will automatically be able to do that. They'll see that, right? But for you, you can do it this way. Bang, multiply, reciprocal. Okay, now what about B? What's the problem with B?
It's a mixed number.
It's mixed. And they don't even try to, here, I'll give you even a hint. When you're doing addition and subtraction of mixed fractions, change them to improper, do the math, and then change them back. You'll have less stress on yourself and your students. So we want to take both of these, the 4 1/6 and the 2 1/3. Before we do anything about multiplication or any of that, we want to change them both to improper. So what's the rule again? What do we do with the 6? Times it by
4.
and add 1, right? What do we do with the 3? Times it by 2 and
Add 1.
add 1. Perfect. I think Eric just threw that in chat, didn't he? Hang on. Yeah. There we go. Okay. So let's do that. So then, oops. Let me get back to here. So we end up with, right, 6 times 4 is 24 plus 1 is 25 over 6. And then 3 times 2 is 6 plus 1 is 7. Now that we have them as improper, now we can do the old multiply by the reciprocal, right? So remember, you don't flip the first one, you flip the second one. So times 3 over 7. And then you can multiply straight across, right? So 25 times 3, right, that's going to give us our 75. Our 6 times 4, right, is going to give us our 42, and then we can reduce it. And they do it in, they kind of reduce it on the fly here, which is not a big deal, but we end up with 25 over 14. Okay, now here's a question for you. We started with mixed, we ended with improper. Should we switch it back to mixed?
You said
Yeah.
You normally do, right? And in middle years, you're going to get your kids to always switch it back to mixed. As soon as you get to high school, we don't care, because often we'll leave it as an improper because we're going to do something useful for it. Like we do slope, right? Like rise over run. And then we leave it as a mixed fraction, or sorry, improper fraction. But you can change it back to mixed if you wanted to. I'm not too picky. Okay, now this next part. All right, now we're going to get into the whole rational number system. And these are those weird rules that we talked about before, the commutative, or sorry, closure, commutative, associative. Okay, so we're going to cover those again, and they're not going away. So rational number system. When you have a rational number, it has an inverse. It has a negative, right? So for instance, if I gave you 1 over 2, it has an inverse, negative 1 over 2. Where do we put the negative? Do we put it here, in between, or do we put it on the top?
in between?
In between. Does it actually matter? It actually doesn't. But the normal way of writing it is in between, right? So for instance, if I gave you 1/2, I would say the inverse is -1/2, and then the negative would go in front. But technically, you could put it on the numerator. You could also put it on the denominator, right? You could have -1/2, or you could have -1/2, or you could have 1/-2. They all mean the same thing. But the normal way to write it is in the middle here, -1/2. Okay. Okay, here we go. Let's talk about the first property. Closure. Here's a bunch of rationals. A over B, C over D, E over F. We're just going to use them for the next thing. Closure property. Do you remember closure? If you have a rational and you add a rational, what do you get as an answer?
Irrational.
Irrational, right? That's a closure. That didn't change, right? Remember when we did whole number plus a whole number, you get a whole number. Integer plus an integer, you get an integer. That's just the closure property. Okay. Next one. If you go A over B plus C over D, that's exactly the same as A over D plus A over B. Commutative property. Does order matter when you're adding? No. Okay, that's the closure property. Sorry, the commutative property. Sorry. Then the next one was the one with the brackets. Do you remember that one?
Associative.
Associative. There it is. So again, it doesn't matter where the brackets are. So in this case, the brackets are around the A, B, and the C and the D, but they could be around the C, D, and the E and F, right? Basically with rationals, it's exactly the same as it was with integers and whole numbers. Those properties are not any different. The only difference is what we're using them on. Okay, so closure, commutative, associative. That was for addition. And you'll see what happens in the next one. Okay, what about this one? If we have a rational number and we add 0 to it, what do we get? Well, we get the same rational number. So for instance, 1/2 plus 0 is still 1/2. -3/4 plus 0 is still -3/4. It doesn't change. That's the 0 as an additive identity. Additive inverse. This is what we talk about when we do algebra. Remember, if I said 5, my inverse would be -5. If I had -7, my inverse would be 7. And what happens when you add those together? You always get 0, right? So look at this here. If I have 1/2 as my A over B, 1/2 plus my inverse, which is -1/2, I end up with a 0. Okay, that's the rule on this one.
Why is it called inverse?
Because it's on the opposite side of 0 on the number line. So for instance, you would say color-wise, right? The inverse of white is black, right? So the inverse of 1/2, if you flipped it over the number line, is -1/2. That's my interpretation of what inverse is. Don't quote me on that. You'll find as teachers, you make up a lot of things. I'm just joking. Okay. So those were all addition. Those apply to all subtraction also. So let's actually do some practice here with the questions in here. So what we're going to do is when you have two rational numbers, A over B and C over D, when you're subtracting, you have to find, look here, a common denominator, the BD, right? So we have a B and a D. To do that, one of the easiest ways, I think you asked that question on that, the one in the book, right? What was it? 7, 5, and 3. And I just said, you know what? Just add them all, multiply them all together, because that gives you a common one. It's not always going to be the lowest one, right? Low LCD, but it will work. So let's look at an example. Let's do this one. Let's flip here and go right here. So let's look at 3 over 4 minus 7 over 6. Okay, now if you could not find the lowest common denominator right away, if we multiply 4 and 6, would 24 work as our common denominator? Yeah, it would. Yeah, right, Alice?
Yes.
That would. Okay, so that works. You can talk about lowest common denominator later on, but then what we do is we can look. What we got to do is we got to make equivalent fractions. So my 3/4, right? I need to times both the top, the numerator, and the denominator by 6. Okay. And my 7 over 6, I need to multiply both the top numerator and denominator by 4, right? Because basically, if you look at this, I'm multiplying this first one by 6. Basically, I'm multiplying it by 1, aren't I? Because 6 over 6 is 1. And if you multiply by 1, it doesn't change it. Okay. And then the 4 in the second one here. So what we get, look here, we get 18, right? 3 times 6 is 18. We're going to subtract them. And then 4 times 7 is 28. We're going to subtract those. And my denominator is 4 times 6, which is 24. So then I end up with, oops, negative 10 over 24. But do we always reduce our fractions? Yep. That one ends in a 0. That one ends in a 4. So we know both are divisible by 2. So we reduce it down and we, oh, sorry, back that up. That one came up too quick. We reduce it down and we end up with our negative 5 over 12. Okay. Now, this next one, I'm showing you this one. Do not do it this way. Please do not do it this way, because this is probably one of the most difficult ways. And you might have learned it this way, but it is really, really hard for kids to understand. You see, we have mixed fractions. Yeah. Watch this. And this is where I don't want you to do it. I'm showing you this because I don't want you to do it. This one, you take the front part and you end up with your negative 2 minus your 4. But then you got to take your back fractions and you have to add them together. This is the actual way you might have learned it at one time. And it's kind of crazy. And then you do that. Now, and then you end up with your negative 6 minus the rest of this. And you end up with your negative 6 over 11 over 12. How do you think I suggest that you do this?
Change them to improper.
Perfect. Change them to improper. Find a common denominator, subtract them, and then change them back to mixed. Honestly, that's the best way. Should we do it on the board?
Sure.
Sure, let's do it on the board. Give me 1 sec. Stop sharing. Hang on, give me 1 sec. I always just gotta get everything set up here when I do this. I need this one, and I need to share. Share the screen and share. Perfect. Okay. Now that my headset's working, you can actually hear me as I walk around. Let's see. All right, let's go to a new screen. Damn electronic pen. New screen. There we go. New screen, pen. That's fine. Okay, so this one is negative 2 1/4 minus 4 2/3. Okay, so let's just convert these first. So we go 4, remember, 4 times 2, right? And then plus 1. So what do we get? 4 times 2 is 8 plus 1, so we end up with negative 9 over 4. Minus, right, multiply, add. So 3 times 4 is 12, plus 2 is 14 over 3. Okay. So far, so good? Now, what's my common denominator?
12.
12. So I need to take the first one, this one right here, and I need to multiply both the top and the bottom by 3. Is that correct?
Yeah.
And I got to take the second one and multiply both the top and the bottom, numerator and denominator, by 4. Okay, so here we go. So negative 9 times 3, 27 over 12, minus 14 times 4, 64 over 12. Now what do I do?
You subtract.
But to me, I might want to do one of the methods I used yesterday. And if you remember, if you're subtracting, it's the same as adding the inverse. Do you remember that from yesterday? So add the inverse, which would be this. I like this one better because I can see, oh, I'm not taking a negative and subtracting something. I'm just actually adding 2 negatives, right? So that rule we talked about yesterday, additive inverse, comes into play. So now I could just add them together. I got 2 negatives, right? So I end up with what's 27 and 64. What is that? 91? Is that right? Over 12. Whoa, what happened to that 12? Fell off. There we go. Now, like I said, in high school, we would just normally leave that as an improper fraction. But since we started with mixed, should we convert it back? Sure, why not? 12 goes in how many? 91, how many times evenly? Take a guess.
7.
7? So let me check. 12 times 7, right? 4, 184. Is that right?
Hello.
91. Oh, I did that.
Yes, it's right.
Yeah, it's right.
Okay, so -7 and what's left over? Did I make a mistake somewhere? I think the sheet's wrong.
Yeah, you put it 64 and it should be 56.
Oh, thank you. Oh my, hey, isn't it great that you got a math teacher that can do math? So how many times? What is this? Let's fix this. Thank you. What do we got here? Negative 3, 7, 83. Is that right? 3 and 1. Yeah, 83 over 12. Okay. So 12 goes into 83 how many times?
6 times.
6 times. Thank you very much. 2 was that 72? Yeah, okay. Perfect. There we go. So -6 and 11, 12. So it is right. Okay. I'm glad you can do math. I sure can't. I think that's everybody's biggest fear when they become a teacher is making mistakes up on. I make a lot of mistakes. Don't stress too much. Okay, does that make sense? You may think that's a few more steps, but I sure like that a lot better than doing it the other way where you split the whole numbers and split the fractions. Okay. So now we have a couple other, let's go back to the rules again. The rules that we just covered, but those were for addition. We're going to do them for multiplication. Stop sharing. Give me a sec here. This one. Share. Yep, that's the one we want. Current slide. Okay, so then we did that. Bam, 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 bam. We did all that already. Okay. Okay, so what we got here is properties of multiplication. So we have our 3 rational numbers, A, B, C, D, E, F. First one is closure property. Closure property is if you have a rational and you multiply it by a rational, guess what you end up with?
A rational by
A
any
rational.
chance?
A rational. That's the same closure property for all of them. It doesn't change, right? Okay. Then we have commutative property. Does it matter the order when you multiply?
No.
No. A over B times C over D is exactly the same as if you flip them around. Doesn't make any difference. Okay. Associative property is the one with the brackets, right? If you have the brackets, you can move the brackets around. It makes no difference, right? Because it's all multiplication. And that's kind of the nice things about multiplication. Now, because we're multiplying, we have a couple other rules we always got to look at. And the big one, and this is the main one, is the distributive property. And we've talked about this one already. It's when you have something like here, you have a rational out the front and you have something within the brackets. Well, what that means is everything that's in the brackets here, the C over D and the E over F, is multiplied by A over B. So you could see A over B times C over D plus A over B times E over F. And you'll see that a lot. If you remember doing, do you remember FOIL? Do you guys remember with variables and numbers and we did something called FOIL? That's distributive property. It doesn't change. Okay. So distributive property. Oh, sorry. Go ahead, Alice.
What is foil mean?
What is what? Sorry.
Foil.
Foil? Is it?
Yes, foil.
Foil. Okay. Give me 1 sec. Let me show you. Give me one. Hang on, stop sharing. Give me one sec. Problem is I always got to switch to my board and it just takes so long sometimes. Share this, share. I could use, Zoom actually has not a bad whiteboard. I should probably use that more often. Okay, FOIL. Let's see if you remember this. This is when you had two. Here, let me give you a breakdown of distributive property real quick. In the form, you probably remember it. So 2, right? And then you had like x plus 3, something like this. Distributive property means you distribute everything to that inside there and it's multiplication. So you end up with 2x plus 6. Don't stress about this too much now. We're going to cover it in one of the chapters coming up. But FOIL was this. Something like x plus 2, x plus 3. When you had two binomials, and because we do it so, we do just distribute it properly so much, we actually do it like this. We go, the first two ones is your F. Your outside ones is your O. Your inside ones is your I. And your last ones is your L. So that's where the FOIL comes from. And it's just the order that you multiply stuff in, right? So x times x, x squared. Outside 3. Oh, sorry, my board needs to be shifted here. Plus 3x, plus 2x, plus 6, and then you combine like terms. Do you remember that, Alice? Do you remember doing that?
I don't know why I don't remember.
It's not a big deal. It's coming up again. When we go to the algebra section, we cover it again. But FOIL is just the quick way of doing distributive property because it's so common in multiplication. Right? It was just a faster way of doing it. Okay, let's get back to this here. Hang on. That one. Share. There we go. Okay, and current slide.
But I'm on second.
Okay, so hang on. Lost where I was. Distributive property. Okay, so that. Let me go back up here. So that's the distributive property over addition, because there's a plus sign here. This one is distributive property over subtraction. If you notice, they're exactly the same, except for instead of adding, you subtract, right? That's the only difference. Yeah, no worry, Christina. Thank you for letting me know. So that is the same one as addition and the same one as subtraction, but it's still the same rule, right? You just distribute and then subtract. Okay, now the last two rules here. When you multiply by 0, what do you get? 0. That's different than when we added 0, wasn't it? Remember when we did a rational, we added 0? We still end up with the original rational. The difference in this case is when you multiply 0, you end up with 0. So no matter what your rational was, it basically ends up as 0. Now, what if you take your rational and multiply it by 1? Well, you end up with the same rational. So for instance, 1 times 1/2, right? My 1/2 is my rational. I still end up with 1/2. Okay. So that's multiplication by 0, multiplication identity for that one. Let's talk about, let A be a rational number. Is there a multiplicative inverse? Okay. So for instance, if I have 1/2, is there a unique rational? Yeah, 1/2. If you flip them, you end up with 2/1. So what is 1/2 times 2/1? What do I always end up with? Look here on the screen. What do I end up with? A 1? Yeah. And that works for anything, right? So for instance, if I had negative 1/3 times, right? Do the next part, negative 3/1, I still end up with my positive 1. Well, that's kind of cool. What about 4/5? Right? 4/5 times 5/4, I end up with 20/20, which is 1, right? So this is there is a multiplicative inverse. And all you're talking about is when you multiply by its flip. Okay. Now, what I got for you for the last part here, before we do some questions, and then we'll only have time for one quick activity, is two examples on multiplication. Now, this first one, take a look at this. You have a mixed fraction, right? And you're timesing it by 15. Honestly, I don't like the way they do. Again, look how they do it, right? They take the 2 times here. They take the 2 times the 15 and the 2/3 times the 15. They take it and break it apart. I don't like that method, and I think that's kind of a weird way of teaching it. What I would do is take that mixed fraction and turn it to what first? Mixed fraction turn to
Improper fraction.
improper, right? So that would, to me, that would be a way easier way to teach it, especially if you're doing addition, subtraction, multiplication, and division with kids. You want to keep this, you want to keep the consistency the same. You don't want to start throwing multiple rules at them. Okay, so to do this one, if we were to do it as changing it to an improper, we would take 3 times 2, right? Which is 6 plus 2, which is 8. So we end up with 8 over 3, correct? And what's 15 over? What number is 15 over? We just don't write it in.
1.
1. So you have 8 over 3 times 15 over 3. And then could you multiply it out and then reduce it? Yeah, you could do that, right? That would be the easy way. But this is interesting the way they do it, right? 2 times 15, they break it down into here, 30, and then 2/3 of 15. This is where kids are going to struggle with the 2/3 of 15. So, but again, when you teach it, it's up to you how you break it down. I prefer the method of changing it from mixed to improper. Okay, next one here. So what we got here is 2 over 3 times 7 over 4 minus 2/3 times 1/4. Well, this is interesting. Do you see that both the 7 over 4 and the 1 over 4 are multiplied by 2/3? Yeah. So what we can do is we can think backwards. We can kind of do a backwards distributive property. So the 2/3 are the same, but what we can do is we can take the 7 over 4 and the 1/4, and we can actually, if you look here, just subtract them. This is kind of a neat way of looking at this question, because you could technically, you could go 2 times 7, 3 times 4, and you'd end up with 14 over 12 minus 2 over 12. You could do it that way. That works also. But this is kind of a neat way of doing it. 7 over 4 minus 1 over 4 is common denominators. So you can actually just subtract them. Oops. And you end up with your 6 over 4. And then you can multiply 12 over 12, right? Which is 1. Now, if you did this the other way, what do you get? 14 over 12 minus 2 over 12 gives you 12 over 12, which is 1. No matter how you look at it, you'll still get the answer of 1. So there's 2 ways to do that question. It doesn't matter to me which way you do it, and it doesn't matter when you're teaching kids which way they can do it. They can do it either way. Okay? Okay, so wow, okay. So here's what I want you to do. We're running massively out of time. Sorry, I know I say that every class. Here's some questions to do. Let's take till 25 after, right? So about 5, 10, a little less than 15 minutes. Do some of these questions, because these ones are, let me look at here. 302. Yeah, these are actually doing some multiplication questions. Multiplying, reducing, dividing, reducing. And then 6.4 on 313. Same thing. We're just, what properties? And then you're doing some, now a lot of these ones on page 314, when you get to them, are mixed fractions. You might want to change them to improper. It's probably easier. Anyways, work on that till about 25 after, and then we'll do one quick activity at the end, just to tie everything up. And who was it? Was Lori? Is Lori back? I didn't look. Lori's back, right? No, she's not back yet.
I'm here. I
No,
think that you. Oh, what Laura are you talking about?
the one that needed help with Genius Scan, that was Lori Martin, right?
No, that was me.
Oh, sorry, Lori. Okay, so you downloaded Genius Scan, is that correct?
Yes, I did. I tried. Can you check your email if you received it?
Oh, well, let me take a look.
Because I tried. It says.
Lori Campbell. Hang on. Well, let me look here. I got something from Lori Campbell.
Look for mine too, Brian. This is Kyle.
I don't see yours yet, but let me look here. Hang on. Sometimes it takes a while. Let me look. Did you just send it, Kyle, or was it sent before? Let me see. Kyle. Okay. I just got 3 recently. One from Holly, one from Terrence, and let me double check yours, Lori. Let me open it up here.
Yeah, because I want to see if all the pages came.
Yeah, give me a sec. I got to move the screen here. Hang on. Lori Campbell. Hang on. One. Oh yeah. One. Hang on. Let me count here. 1, 4, 5, 6, 9. 9. Looks like it's missing. I think you're missing 1 page here. Unless it
many
came.
pages?
Oh, no, there it is. It just came as a different spot. 15, 16, 21, 25. Yeah, I got everything, Lori. That works.
Okay.
Right,
I was
Brian?
just-
Oh, sorry.
Yeah, go ahead.
Do you have all the pages too?
For who?
Terrence.
So for Terrence, let me double check.
Yeah.
Hang on. Oh, that's weird. Yours came as all separate ones. That's weird.
Yeah, I had trouble.
No
sending it.
worries. Yeah, I see 6 pages here. Let me open one and see. Yeah, it looks like everything came for yours too.
Okay, thank you.
For those that sent out, I don't know if you noticed this. I sent you back a quick message like I received it, I got it. So that way you know that it came to me. And if you didn't get that, then you know you did not get it to me yet. Because Kyle was just asking if I got it yet, right? Kyle, is that what you? That was you, right, Kyle? Okay. No, I haven't got anything yet. Oh, I just got one from Lee.
As far as mine assignment goes, Brian, just so you know, I may not be able to put it in one folder. I'm not sure if we figured out exactly how to do that. I'll try to do it, but if I can't, then we'll just do it like it is. So.
Yeah, that's no worries about that. I mean, we were just trying it. We were just trying to make it easy, but it was fine last time. It just took me a little bit to get it all printed off, but it was okay.
Right. Okay. Well, I'll get it to you at the end of class here. I don't think it's been
Perfect.
sent off yet. I just finished it though.
Yeah, no problem. Yeah, you
Okay.
have like, you still got like 45 minutes or so, or if you need a little more time, like an extra 45 or an hour after that, that's fine. I just won't be able to print it off tonight. Sorry, who just talked to me?
Me, Lori,
Lori.
again. Campbell.
Oh, Campbell. Thank you. Yeah, go ahead.
Okay. That's where I'm kind of struggling with the Genius scan.
Right.
Is there another place, like say I can do the work on, like say I have an iPad, is there a place where I can download an app to do the work on that and then just submit it that way?
I think, hang on. Who is it that does that already? Somebody already does that for me.
I do that.
Alicia? Is that no? Who is it?
Nicole.
Nicole, thank you. Yeah, Nicole does that already. Nicole, how do you do it? Because you do it on your iPad too, right?
Yeah, I mean I have an Apple Pencil, so it's way easier writing. but-
Oh yeah, that's easier with an Apple Pencil. Yeah, if you don't have an Apple Pencil, then it's kind of a pain.
Lori, do you have the Apple Pencil, don't you?
Yeah, I do. That's why I
Yeah.
want that.
Yeah, I
Mine
sent
to
you a
find-
chat, but it's called Good Notes.
Good Notes.
Yeah, I sent you a chat. If you would check it, I put all the info in there. But basically, like when you go to the website, you can, like when you're on the assignment page, just click that, you know, that button that's got like a square with an arrow in it. You can click that and it'll open it in Good Notes for you right away. And then you can just edit it in there and send it from there.
Oh, okay. That's all I want to know what it was called.
Yeah, Good Notes 5, I think, is the most recent version.
So this is what you're saying. You go to the assignment, right?
Yep.
And then you click which one?
There should be like, it's gonna look different on every device, but
Oh yeah, because it's on an Apple. That's right.
yeah, like export or open with or download, whatever you need to do. And then if you're opening it on the iPad though, it'll automatically give you the option to load it right into Good Notes once Good Notes is installed.
Yeah. You guys are lucky. You get access to the iPads. I don't have one, so I've never really used one before. So must be nice.
Yeah, they gave them to us in our first year, every first year Pent.
Yeah, I
student.
remember that. I remember actually, well, because I've been in Penn for 20 years. I remember when they struck the deal with Apple and then people started getting them. It was so cool. I'm like, wow.
Yeah, the guy was like a alumni. He's a Pent alumni and he works for Apple, so he arranged it.
Yeah, that's a good deal.
I have a question.
Yeah.
Number 12 for assignment 3.
Oh, good grief. You in
So-
assignment 3. Hang on.
Sorry.
No, it's okay. Just, I gotta find my book. Question 12. Yeah, go ahead.
So rewrite the fractions using the least common denominator. So the denominator 4, 6, and 9, I just have to find the least common multiple for those 3 numbers, right?
You got it.
Okay.
And here's the deal. And this is something I always tell kids. It's always going to be based on the bigger number. So for instance, the biggest number is a 9, right?
Yeah.
So that's the one you work through. So you can even do this in your head. Just do multiples, right? So 9 times 1 is 9. Doesn't work. What about 9 times 2? That's 18. 6 goes into 18, but 4 doesn't, right? So that doesn't work. 9 times 3, 27. 9 times 4, 36. Oh, that one looks interesting, right? So you can do it without doing all the extra work. But if you're ever finding like going through multiples in your head, pick the biggest one. It's always the faster way.
Yeah, that's what I tell my students too.
Look at that. You know what you're doing. By the way,
While you're on assignment 3.
Sorry.
Oh, sorry, finish. No, go ahead.
By the way, Kyle, that was funny about your burgers and foil. I get that. And I finally went back and read that. So thank you. That was funny. Okay, sorry. What was your question?
Sorry. On assignment 3, number 20.
3, 20.
Yeah, I just want to double check because it has 7 over 8x plus 9 over 8 smaller than 47 over 7. What are we
Is less
doing
than,
with that?
yeah.
What are we doing with that x? Like we can't combine the first 2 fractions because it's variable, or what are we doing?
Well, no, you can't because they're unlike terms. But for instance, let me give you an example. If I gave you 7x plus 9 is less than 47, how would you solve that? Well, you'd rearrange it, right? You'd move the 9 over to the other side, and then you divide by 7, right? You'd solve it like you would normally do algebra. The only difference in this case is you got fractions. So how do you get rid of that 9 over 8? Right? You subtract 9 over 8 on both sides. And then how do you get rid of that 7/8? Well, you divide by 7/8. That's one way, but there is a way faster way to do that question. And I can show you that. Well,
So you can still do it that way even though there's no equal sign?
Oh, yeah. Well, it's an inequality. It's the same as treating it like an equal sign. The only thing you have to remember, and I don't know if you remember this from when you did it, if you multiply or divide by a negative, you have to remember to flip your inequality. Does that sound familiar? Do you remember that?
Yeah, there's no negatives in this one, so that's nice. One
So you're
less
good.
little
Then you're
step to
solid. So
think
then the
about.
inequality is going to stay the same.
Okay, so my first instinct was to like put them all common denominator and then do it that way. But
Here's even a better way. Give me a sec. I'm going to throw it up on the board, and then we're going to do this closing activity. This you might remember this, and hopefully you do. This is a real cool way of doing it. Let me do that, and then share screen. Let me do this and share. There it is. That's the one I want. Okay. Actually, let me give you a different example, but it'll be close to this one because I don't want to give it all the way away. Let's go back to 1/2 x plus 3 over 4 equals 5 over 12, right? This is something you did at one time, and it's very similar to what you did, except the only difference is it's not an inequality. One of the cool ways of doing stuff like this is, can you get rid of the fractions? Yes, you can. If I do this, and I multiply something by, if I multiply each of these terms by something, because I'm just making an equivalent expression, or an equation in this case, I can get rid of the fractions. Now watch. If I multiply by 12, 12, and 12, watch what happens. What's 12 times 1?
12.
Divided by 2 is?
6.
So 6x. Okay. What's 12 times 3?
36.
Divided by 4?
9.
12 times 5?
Something. Okay.
Divided by 5 is, divided by 12 is 5.
Yeah, that.
Now, that is way easier to solve, isn't it?
Okay, okay.
So
I see
here's
what
the
you're
kicker.
doing.
Here's the kicker. On that one, what could you multiply everything by to get rid of the denominators?
Well, didn't you just multiply everything by 12? Is that what you're asking?
Well, I did on that one on the board, but on the question on question 20 in the lesson.
Oh, I don't know. 7?
No, because that won't get rid of the 8s.
8?
If you don't remember this method, it's not a big deal. It's just a shortcut, right? The method I'm showing you. You could do it the long way, right? Subtract 9 over 8 from both sides and then divide by 7 or 8. You can do that. You will get the right answer. Trust me.
Okay, so why wouldn't you divide everything by 1/2 to isolate the x?
Oh, you mean on the example I did?
Yeah.
Because a lot of people don't like working with fractions. And if you do 3/4 divided by 1/2 and 5/12 divided by 1/2, wow, that's a lot of work. So what I did is because I multiplied everything by 12, I just got rid of all my fractions. All I did was make an equivalent equation. That's all it is. We're on lesson 3. We haven't got to me teaching you that yet. So you might have to wait till next week.
Okay, I'll just be patient. That's fair.
Okay. So let's we got just a couple minutes left. I would like to close with one little activity, please. Hang on, stop sharing. Here we go. So let me get to the right one here. Hang on. You guys get me so excited about math. I misplace everything. That's not what I want. I need this.
Did you? Oh no. Did you talk to Anthony?
Whoever that is, please mute your mic. Who is that? I don't even know. Okay. So the one activity, if you look at what I've done for day 8 here, there's a bunch of stuff you can look at. Take a chance, take a bit of time and look at this stuff. It's the Folded Fractions website, which is useful for figuring out fraction strips. Really, really useful stuff. There is tons of stuff on this toy theater. It's a free website. There's a lot of stuff here. Fun fractions when dealing with and if you have these shapes, you can talk about fractions this way. But what the one I want to cover is fall fraction words. And this is a neat activity to do this. Okay, so here's what I want you to do. Here you have a fraction and you have a word. You have a fraction, you have a word. So for instance, start with the first 2/5 of Scout. So the first 2/5 of Scout would be the S and the C. So you put your S and your C here, okay? And then just try to fill in the rest of it. It's a kind of a neat little activity just to deal with fractions. And if you can make fractions fun for kids, guess what? They'll learn it. If you make fractions boring, they're gonna hate it. So try to do this little fall fraction things and see if you get the proper words here. Oh, I need this. No, this.
Got the first word.
Hang on. Try to do the second and third word. We'll wait till everybody gets them. Because I have candy to give out. Oh wait, no, I don't have candy to give out. Sorry. Dang, I need virtual candy, right?
I was promised candy before last science class, Brian, and unfortunately there was a mix-up with the mail, right? So I didn't get any. Break my heart and promise.
I feel normally when I teach this in person, and we actually do. For instance, the activity that I do with this fraction one is a Skittle activity, and it's amazing. And you actually get to eat the end result. But the problem is virtual. You just can't do it. Sorry. Blame COVID.
Yeah.
That's a neat activity.
There's so many different things out there when you start looking that deal with fractions, right? I mean, you can invent stuff on your own, but there is so much stuff that's already done that's just amazing, right? The problem is you got to kind of wander through it a lot to find what you really want.
That's the good thing about math. It's full of games.
And that's what a lot of people like. And the good thing about the games is that actually there are really, really good ones to teach math. Like we were talking before about that, right? That book, that Boxcars and One-Eyed Jacks, right? This is a great one because if you look in here, I can actually go in here and find, I bet you this has a fraction one, number systems. So here we go. Adding integers, subtracting integers, plotting integers, right? There's lots of stuff.
Right.
Linear,
After all, Jeff,
sorry, what was that, Alice?
I have a quick question after, if I have time.
Yeah, no problem. We'll do it once we finish off class. Then people can leave because I don't want to keep them. But okay, so did you guys get your words? First one?
Scarecrow.
Scarecrow. Good. Okay. Somebody else can answer. Somebody else give me the second one. Anybody? What was that? You said it. I didn't hear it.
Autumn.
Autumn. Excellent. Yeah, autumn is correct. And somebody different, give me the third one.
Squirrel.
Squirrel.
Right. That's, when you're when you're easily distracted, squirrel, right? Squirrel, squirrels. Okay. Okay. So we're done. Just give me one sec here. So next week on Monday, we are going to do the midterm review because the midterm is Tuesday. If you want, can you look at that stuff this weekend? Would I recommend you look at that stuff this weekend? Yes.
Yeah.
And it is on the website. So if you look here, day 9, midterm review. If you click on this on the website, oh, sorry. I know you can't see that. I just realized that. Share screen. Drives me nuts here. Share screen, right? Day 9 right there, Monday, May 17th. Click on that. That'll give you the review. Lots of questions here. And if you look at the end of it, the answer keys at the end, so you can take a look at it. Okay. That's what we're going to work on Monday in class. And then on Tuesday, you will sign in just like we did before and log into ZipGrade. And we're going to do, it's 50 questions. So you might want to also before then, I don't know if you'll need it. Probably a good idea. Print off the formula sheet. Yeah. Because you got a couple days to do that. If you have to get into school or go find somebody with a printer or send it to them so they can print it off for you. And the formula sheet is just 2 pages there. We're not going to use all of these right off the hop. A lot of these are coming up later. In fact, I don't think we'll use any of these, but you might as well get it off, print it off anyways. Okay. Are we good? For those that need to stick around and ask questions, you can. The rest of you have a wonderful Friday tomorrow. I still got to work like most of you, and then have a great weekend.
Yeah, same to you, Brian. We'll see you on Monday.
On Monday. Perfect. Let me just stop recording here. Give me one sec. Stop recording.